So first of all, some definitions. Angle is a figure consisting of two different rays with a common initial point. So for example, ray BD and ray BA are forming angle 1. Now, when you name an angle, you can either throw a number in the interior of it like that, and it makes it easy to talk about angle 1, angle 2, angle 3, whatever in the picture, or you can name it with 3 letters, and you want to make sure that the middle letter is the vertex of the angle. So that would be angle ABD, or angle DBA. But what's special about the middle letter here is that that is the vertex of the angle, or in other words, that common initial point of the two rays. So for the angle, it's called the vertex. For the rays, it's called their initial point or their endpoints. Okay, so I'm going to jump down to vertex for a minute. The common interior point, the common initial point of the two rays that form the angle. So for angle 1, the vertex would be point B. The vertex of angle 2 is also point B. Okay, for sides of an angle. Sides are just the rays that make the angle. So the sides of angle 1 would be ray BA and ray BD. Sides of angles are rays, not segments or lines. They're rays. Okay, and then interior, exterior. So let's say we're talking about the interior of angle 2. So angle 2 would be the angle formed by ray BD and ray BC. The interior is just like it sounds. It's the inside of the angle. So points in the interior of angle 2 would be all these points inside of here. And that would be an infinite region. So any of these points that are inside of here would be considered in the interior of angle 2. Whereas the points that are not on the side of the angle where we have the 2 there would be the exterior. This stuff is the exterior or the outside of angle 2. Now notice the exterior of angle 2 is the interior of angle 1, but in relation to angle 2, that's the exterior of the angle. Okay, there's a definition down here that's talking about exterior and interior, but the idea is really pretty straightforward. Okay, so just a notation reminder. Some of us are forgetting that ray AB and ray BA mean two different things. Ray AB means start at A and go toward B. Okay, your starting point is the first one that you write down. So that would be ray AB. Ray BA is a different ray. It's starting at B. Oops, sorry about that. It's starting at B and going toward A, so it would be going in the opposite direction. Now they are not opposite rays because they aren't sharing the same initial point, but they are going away from each other. So if you were looking on a single line, you would have A and B together. Okay, and it would be like this would be ray BA, and this would be ray AB. And again, they're not opposite because they overlap at all these points inside here, but they do go in opposite directions. Okay, let me get rid of that. All right, so the first letter is the initial point, or sometimes we call it the end point. Okay, so those do mean different things. All right, some more terms. Two angles that have the same measure. We talked about this with segments. Segments that have the same length are called congruent, and angles that have the same measure are called congruent. Congruent just basically means the same size and shape. When we measure angles, we're going to be measuring in units called degrees. There is another unit of measurement that's common in math, which are called radians. And when we use our calculator later this year, we'll talk about how you have to make sure your calculator's in degree mode, because in geometry we use degrees. It's just like the difference between inches and centimeters, just two different ways of measuring angles. But we will be working in degrees. Okay, so down here you see a protractor. A protractor is what's used to measure angles. And remember that a straight line or a straight angle right here is 180 degrees. Okay, so as you look on the outside here, as you go from left to right, counterclockwise, notice how the numbers are going up. And then if you were to go the other way, if you start on this side and go, that's counterclockwise. That way the numbers are going up. So when you're reading the size of an angle, so for example, the first one there is asking you for angle RSP. So angle RSP is, let me get rid of this. Angle RSP is this angle right here. Okay, so we see that that is hitting either right here at 65, or it's hitting at 125 if you look at the numbers this way. So which one would make sense? Well, we're going from the left to the right in a clockwise fashion, which means that we're going to be using the outside numbers because this is an acute angle. So going this way, we know that it would be 65 degrees. That's what would make sense. Okay, so that measure is 65 degrees. And then the measure of angle PST from here to here. Well, since the big angle measure, RST, since that's hitting right here at 130 degrees. Okay, and this was 65 over here. 130 minus 65 would mean that the leftover angle here would also have to be 65 degrees. So the measure of angle PST is 65 degrees also. And since they both have the same measure, that makes them congruent. And the same symbol that we used for segments applies here. So we'll see the angles are congruent. Now, I'm again going to clarify something about notation. Okay, you either say angles are congruent or their measures are equal. So if we wanted to say this in a different way, we would say the measure of angle RSP is equal to the measure of angle PST. Okay, or the measure, let's say you're talking about angle 3, is equal to the measure of angle 4. Okay, these are numbers. Numbers are equal. That's different than saying angle 3 is congruent to angle 4. That's referring to the actual angles themselves. Objects are congruent. Numbers are equal. So again, I'm going to be a little bit picky on that notation. When you write the measure here, that should be an equal sign because those are numbers. When you write the congruence, that goes with the actual angles. Okay, so some more terms. I'm sure you've heard these before. An angle whose measure is 90 is called a right angle. An angle whose measure is between 0 and 90 is called an acute angle. Oh, it's such a cute little angle. And then an angle whose measure is between 90 and 180 is an obtuse angle. And an angle whose measure is equal to 180, that means it would be a straight line, is a straight angle. Okay, so we have one more postulate. Remember, a postulate is a statement that we assume to be true. It's supposed to be kind of an easy to understand, obvious statement. So this postulate looks a little bit complicated at first, but actually it's pretty easy to understand once you look at a picture here. Okay, so it says let B be the interior of angle AOC. So let's say this is angle AOC. And remember, the vertex is going to be the middle letter of the angle, so that would be angle AOC. And B would be some point in the interior of the angle. So then we're going to draw a ray through point B to create two smaller angles. B is in the interior of angle AOC. Then the measure of angle AOB, which is this angle measure right here, the measure of angle AOB plus, here, I'm going to write it this way. Let's say that I call this angle 1 and I call that angle 2. Then we would say the measure of angle 1 plus the measure of angle 2 equals the measure of the big angle, which is AOC. This is the same exact idea as the segment addition postulate. Angle plus angle is equal to the whole angle measure. Okay, so this problem says draw angle ABT. So angle ABT. I'm going to go this way this time. It doesn't really matter which sides of the angle A and T are on, as long as B is the initial point or the vertex of the angle. Okay, point L is in the interior of the angle. So here's point L. Okay, and then the angle addition postulate would say that the measure of angle ABL plus the measure of angle LTB is equal to the measure of angle ABT. Okay, ABL plus LBT is equal to ABT, or ABL plus LBT is equal to the measure of angle ABT. So again, if this were like a 20-degree angle here and a 60-degree angle here, then the big angle measure would be 80. Not hard to understand, just the notation looks a little weird at first.